I'm Dan Galpin.
And hi, I'm Lyla.
And we are going to talk about the adventure of navigation. And we're going to do this really fast because we have a billion slides, so keep up. All right, so why did we decide to do navigation? So basically, there are a lot of problems we saw that developers had. One is that navigating between activities wasn't very testable. Plus, activities are more expensive in terms of resources, coupled to manifest metadata, while fragment transactions were tricky. And a cause of crashes due to things like illegal state exceptions. Synthesizing the backstack after a deep link was challenging, particularly with fragment-based apps, and passing arguments was ultimately unsafe. And all this required lots and lots of error-prone boilerplate. And plus, things weren't consistent, and this was for both developers and users. So like deep links into the application sometimes synthesized the entire backstack, and sometimes not at all, sometimes just a piece of it. The navigation drawer was used to navigate to different hierarchies and different patterns with unpredictable results. Menus sometimes added to the navigation hierarchy and sometimes switched to a different hierarchy. And bottom navigation sometimes navigated and sometimes displayed different views and the way tabs do. And honestly, I think most developers were unsure about what the real difference between up and back actually is. So we decided to actually get opinionated and release principles of navigation. And what does that really mean? Well, one of the things we decided apps should have a fixed starting destination. And this is like the screen that the user sees when they launch your app from the launcher. And it's the last screen seen when you return to the launcher. And if your app has a one-time setup flow or login screens, even if they are the first thing the user sees, this is not actually considered the starting destination. And now the explanation you've all been waiting for, the epic difference between up and back. And so the idea was that up would navigate up the hierarchy, and this allows one to travel up to the next hierarchical navigation level rather than moving within the fragment backstack, which could, in theory, be very large. Like imagine if Gmail added a fragment to the backstack for every message you clicked. You'd be super happy to have a way to get out back to the hierarchical parent fast. But there are two problems with this. The first is that the buttons look exactly the same to the user. There's no clear indication that the button on the left moves up and the button on the right moves back. And the second is that the buttons look essentially the same to a developer. So this confusion means that some developers implemented it one way, others did it another way, and even worse, we had minimal tooling to help developers implement it correctly, particularly if you're using a hybrid like fragment and activity app, so it's not consistent. So we got rid of the navigate up the hierarchy thing. Everyone can cheer. And now we recommend these buttons have the same behavior whenever they are on the screen together, as long as you're navigating within your task. Now, if the user has reached your task, your destination, while in the task of another app, then back should take you back out of the app immediately, while up should take you to the start destination. And that's it. Fairly straightforward. Hopefully users will get it. And the up button should disappear when at the starting destination because it cannot be used to exit the app. Problem solved. All right. So when deep linking, this is the second principle. I know there's not many. You should always be able to navigate back to the start destination using up, which should allow you to get to the rest of the application. Now, this doesn't necessarily mean that your deep link needs to have the exact same backstack as one that the user had when they got there from within the app. An example of how not to do this is what Calendar does, where there's no way to get to your schedule from the notification. How many people love that? At least the UX tries to make it clear that it's a dialogue, but this one drives me a bit nuts. Ideally, it would look like this. You would have an up button, it would take you back to the main calendar view, and people would cheer. The overriding principle of all of this stuff is to be consistent. And hopefully, users will begin to expect this behavior, leading to happier users. And now Lyla is going to give us a quick tour of the navigation component.
OK, so we're going to switch gears to actually talking about the navigation component. So really quickly, who in this room has actually used the navigation component at this point? OK, cool. So it sounds like we probably do need a quick tour of the navigation component. So to start you off, here's kind of what you need to add in Gradle. So the navigation component isn't necessarily a single dependency. So the first one is the main dependency up there, which has everything you need to get sort of basic navigation to work and have navigation graphs. Next, we see the navigation UI dependency, which is very important because it provides a bunch of static methods that help you set up patterns like menus and toolbars. And finally, we have the navigation args plugin, which generates code for you so that you can do a lot of things with type safety. And finally, there's a dependency for testing.
Yeah, there's a lot of stuff to this, is what we're saying.
Yeah, there's a lot of stuff to it. Don't forget some of these things. If you're writing Kotlin, you just pop on a little KTX to the end of those, and you don't need to actually have the other form of the dependencies, which is for Java. OK, So as a broad view, the navigation component is made up of 3 parts. First, you're going to have this new navigation resource. It's a completely new resource, which is a XML file, but it can be visualized like this navigation graph that you see here. Then we have a layout element known as the nav host fragment, which is usually going to be added to your activity layout file. And finally, there is this navigation controller class, which is what you actually use to do the navigation. So navigation graph is made up of a bunch of things known as destinations, which are kind of like the screens of your app, or the contents of your app. And then these destinations are connected by arrows, which are also called actions. Okay, so the actions only show the possible paths that a user can take through your app. They don't actually do any navigation themselves. You actually have to set up that code yourself. So the nav host fragment is going to be sort of located at one of these destinations that is in your nav graph. And the nav host, like so. All right, and the navigation controller is what's actually used to change what destination that you are at. Why is this? Okay. So you can navigate directly to any destination using its ID, as we see here, because all destinations have IDs. Also, all these actions that we talked about before have IDs, so you can also navigate via action. So some benefits of using this navigation component. So first of all, the fact that you have this fancy nav graph is kind of cool. You can actually now visualize all the paths that you can take through your app, and you can also kind of share that with designers or less technical people that you might be working with. Also, it means that there's now one resource that has all of the information about navigation for your app. So we can actually see here, this is part of the navigation graph. It includes things like transitions from one destination to another. It includes things like what arguments or data that you might pass between one destination and another. Also, it reduces boilerplate. So before, this is kind of the table of contents for what you needed to do for a nav graph. It's now essentially been simplified to, for a nav drawer, it's now essentially been simplified to a single line of code to be able to set up a nav drawer, plus the menu for that nav drawer. And finally, it also helps follow the material design principles that Dan was talking about, specifically making sure that you're doing at least what material design says that you should be doing as far as backstack. Okay, so if you haven't used the navigation components before, I'm going to just do a sort of shameless self-plug and say that you should check out the code lab.
She wrote it.
Yeah, I wrote it. So these, this little animation that's playing just is showing all the kind of stuff that you'll be able to do once you get to the end of the code lab, including deep links and other fanciness. So now let's talk about just some general guidance. So the first topic that I want to broach is the difference between activity and fragment destinations. So either of these can be destinations, but thus far I've been showing you this graph that only has fragment destinations in it. But it is possible to navigate to an activity, and here's actually an example of navigating to activity in a nav graph. You can navigate to an activity, but there are no actions that can leave activities. Activities are sort of considered terminal destinations. That's because activities are the thing that actually contains the nav host fragment, and the nav host fragment is associated with a nav graph. So essentially, if you switch activities, you're kind of going to a completely different world. So that new activity is going to have a different navigation map, which is why these destinations are always terminal. So one good way to think about activities is that they are kind of containers for both the nav host fragment they're containers for the nav host fragment, and they also have the global navigation that your app is going to use. Then the fragments themselves are simply the contents that pop into that nav host fragment. Okay, so there are benefits to using this model of a single activity model. First, you end up with a single navigation graph, which is nice because you can see everything that's going on in navigation in one place, and you don't have to manage multiple graphs or be switching around between XML files. It's also hard to make these navigation graphs aware of one another, so it really simplifies things to have it in a single nav graph. Also, as we saw before, when you have a nav graph and it has those actions in between them, you can manage things easily, like transition animations between different destinations, and also property animations on views. And finally, if you're using ViewModels, which is another component that was part of the Lifecycles library, you can have a single activity view model that's shared between all of these fragments if you're using a sort of single activity fragment model. So if you have information that should be shared, like whether the user is logged in or not, this is a great place to put that information and just have it there available for you instead of worrying about passing it around your entire app.
So how many people are using ViewModels here, just for my own edification?
Okay. All right, cool. So you'll get those benefits. Okay, so the next question is, should I be using destinations or actions? So it is possible to have a nav graph with no actions. It just looks like this, because the actions, again, where there's arrows that were connecting things. So that means, of course, then your nav graph just becomes sort of a bunch of screens laid out on a board. But it's kind of nice to have those arrows because then you can actually see them. So we encourage you to use actions and to navigate via actions. This also means that your graph is going to contain more information. It's going to contain that the transition information that I was talking about. It's going to contain what arguments are being passed. It's also going to contain sort of backstack animation that's going on in there, or backstack information that's going on. Okay. Finally, if you use actions, this also enables you to use that code generation plugin that I talked about before, which is called SafeArgs, which Dan is going to talk about right now.
Thank you, Lyla. All right, so what are SafeArgs, you might ask? The SafeArgs plugin is a code generation plugin that helps rid your code of crashes at compile time while eliminating boilerplate involved with argument passing. So as you all know, in Android, IDs are used to represent lots of things, far too many things. Things like actions, destinations, menu items, image views, and you can pretty much navigate to whatever you want, and that will be unhappy. So, using sensible naming conventions does actually help this, but it's even better if you do something else, because it doesn't solve this problem. You can still go and try to nav to an image view, and you will get a lovely runtime crash. Without SafeArgs, you can navigate directly using the ID of an action. But with SafeArgs, you actually get these generated directions classes. And this means you not only know that you're navigating with an action, but you can also see that this action is actually associated with the fragment, because it's named based upon the name of the fragment. And the destination itself if the destination has an argument, you can simply call set on the argument and do it very simply right in the direction. Even better, if the destination doesn't have a default value for the argument, you actually need to supply it in the constructor to the directions object. So this is cool. It'll actually force you to put an argument in and make sure it has the right type. Within the match fragment, we can use the from bundle method to fetch the arguments, and then we can use them as expected. Now, since SafeArgs is a plugin, you do need to add the class path into the project build.gradle file, and then you can apply the plugin to your app build.gradle file. Now, after you've done that, you'll get generated files with directions, for any destination that has actions, as well as arguments for any destination with arguments. Now, like SafeArgs, the navigation UI is a value add for the navigation component, and it helps ensure consistency and eliminates lots of navigation boilerplate. So one of the useful things that navigation does is help navigate leverage the existing navigation controls, from handling the up button to the toolbar or action bar, as well as the overflow menu, along with controls such as the navigation drawer and bottom navigation. Now, navigation UI is designed to implement the material recommendations around each control. For the navigation drawer, this means treating each item as a top-level destination. But what does that actually mean? Well, if Gmail were using this navigation scheme, the primary inbox might be the start destination, and every other destination is a sibling. The hamburger or drawer menu would only appear on the start destination, which would make the navigation drawer a bit more hidden when viewing these other destinations, but it would make the start destination far more clear. So if we were viewing the starred folder, our backstack would consist of the starred messages and the start destination and the primary folder. Then viewing the message detail would add it to the backstack as well. Now, if we were going to slide out the backstack and switch to the important folder, it would then pop the message detail, pop the starred folder, and push the important folder fragment on the backstack. Now, the bottom navigation menu currently works the same way. So once again, we can see that it contains these destinations that are either start destinations or siblings of the start destination. When the title screen is selected, it's the only thing on the backstack because it is the start destination. When the rule screen is selected, it and the title screen are now on the backstack. And you can see that we have the navigation arrow changing appropriately. Now, when the About screen is selected, it and the title screen are on the backstack, and that's always the case because the implement pops off all the fragments before adding the next destination. Now, people have mention to us that for bottom nav, this might actually not be desirable because there's sort of an expectation that states of the fragment of the backstack are actually preserved when switching tabs. So honestly, the team is looking at the best way of also helping developers use it that way. If you do want to use it that way today, you'll have to come up with your own solution. You'll either have to save the backstack and UI state from all the fragments yourself or implement it in an alternate way. But honestly, we are looking at it. So what if you're trying to use these both together? Given that they both essentially do the same thing, the guidance from the material team is no. The main reason is that both controls should always be available for navigation, and both should indicate where the user is within the hierarchy, and therefore both should contain the same information, which means it's kind of useless to have them both there. However, let's say you have an application like, I don't know, this one, which as you can see has tons and tons and tons of different things in it. And the way it works around this problem is of having two controls that want to display all top-level destinations is by hiding the bottom nav all the time, particularly when not on one of the top-level destinations. And then it allows the back key to take the user back, although it still shows the hamburger menu, so it's not clear that that's actually going to do anything. And you can actually implement something very similar to what this app does, using nested navigation hosts with different navigation graphs. And this way, the outer navigation host fragment contains the bottom nav control, which operates on the inner navigation host fragment, but really try to avoid doing this if you possibly can, because if your navigation is this complicated for you, it's going to be even more complicated for users. Now, another thing people have asked us is about tabs. They're like, why don't you support tabs in Navigation UI? And that's because tabs aren't actually supposed to navigate to different screens. They're simply supposed to show different screens within the same destination. So they never go on the backstack. So honestly, implement them the way you've always implemented them, and you'll be good. So bottom nav, the navigation drawer, and the overflow menu are all based on menu resources. Now you can tell navigation you want to use the menu item to navigate to a destination by setting the menu to the same ID as the destination. After you've created the menu resource, you inflate it as you normally would for an overflow menu or action bar in the onCreate menu callback. And then in the onOptions item selected callback, you can check to see if the item has been handled in the navigation controller by calling onNavDestinationSelected. This also makes it easy to have overflow menu items that either navigate or perform some other function. You can set up bottom navigation in the activity with a single call to set up with nav controller. You can handle the up button in a fragment or activity with a toolbar. Just call setup with nav controller. There's no need for the on support navigate up call because you're in a toolbar. Handling the up button in an activity with an action bar involves adding the navigate up button with the on support navigate up as well as set up action bar with nav controller in on create. So again, pretty straightforward. And then we can easily add the navigation drawer to the same thing by adding the drawer layout to the existing action bar with nav controller and navigate up functions, as well as setting this additional setup with nav controller on the nav view that's associated with the nav drawer. I'm sure that was all completely clear. These UI helpers are all written against the public interfaces for navigation, so you can easily change the behavior if you don't like what they do. But know that they really do try hard to follow the principles of navigation. Like we're inside of the setup for the navigation view used in the nav drawer, and you can inside of the callback you can see that on nav destination selected is called with true, which to be fair happens to be a non-public interface. I know sounds like I'm contradicting myself here, but if you look inside of on nav destination selected, that parameter simply makes the destination a top-level destination by automatically popping up to the start destination before adding the new destination using the public interface. There's really no magic here. We're just using our code to follow the principles of navigation. Now, one of the most upvoted questions on Stack Overflow about navigation involves using a collapsing toolbar. The asker wants to know what to do if you have a collapsing toolbar on one of the screens in your navigation graph, and to complicate matters, they also want to use a bottom bar. So, are the toolbar and bottom bar a global part of navigation, meaning they should be defined in our activity? If we don't define in the activity how easy it is to get the up button to work, and what about transitions? Well, it's really hard to do a collapsible toolbar that changes depending on the fragment in the activity because it needs to be nested into a coordinator layout. And the bottom nav, on the other hand, is really easy to put in the activity, and it's visually global navigation. It's on every screen, and the view hierarchy remains the same. All right, so we've answered two questions. With these changes, it's both hard to implement the toolbar in the activity, but bottom nav nicely works there. Now for the up button. As I mentioned before, setting up the up button in the toolbar just involves calling setup with nav controller in the fragment code. There's one version for a toolbar, and there's one for a collapsing toolbar. The final thing to think about are the transitions. For now, if you use navigation transitions and your toolbar is part of your fragment, your toolbar will animate, which looks a little strange, but it's nothing that shared element transitions could fix if they were supported. It's an open issue that the team is aware of. All right, Lyla's going to come back and talk about how to implement conditional navigation.
Okay, so thus far we've sort of talked about things that have been mentioned in other talks and kind of in our documentation. So I wanted to get into some more kind of advanced topics and talk about conditional navigation, which includes all the logic that you need to make navigation decisions. Thus far, our navigation decisions have been pretty straightforward. You click on a button and you go somewhere. But you're often going to get into situations where navigation gets a little bit more complicated. So let's take this example. We're playing a game, and we have to decide whether the user has won or lost, and depending on that, send them to one of these destinations. So a decision needs to be made here, and it might be based off of things like the user's score or what difficulty level they've selected, or if they're playing against another player. So all of this data is usually not floating around in the fragment. It's also better for testing if you are doing this not in your fragment and perhaps in a ViewModel if you happen to be using a ViewModel. Okay, so in 2017, a year before we released the navigation component, we made some other architecture components, the lifecycles library and the room library. And we also released guidance about a possible architecture that you might want to use. So I'm going to be following that architecture, but you can map this on to whatever architecture that you might be using yourself. So here's a very simplified look at what the guide to app architecture says your architecture might look like. So we have our fragment up there at the top, which is communicating with a view model. And that view model can either be a fragment view model or an activity view model, depending on the sort of level that you want to communicate between. And then we have the lower data layers, which I'm not getting into for this talk, but those would be things like your repository, stuff that's communicating with your database, or stuff that's communicating with your network. So in the navigation component world, the fragment is the thing that's actually doing the navigation, but the view model is what's probably going to be holding the data that you actually need to be able to make decisions about the navigation. Therefore, all of this conditional navigation decision making is probably going to happen in the view model. And then we're going to kind of follow the pattern that the architecture guide sets out, where live data is used to then communicate back from the view model to the fragment. So any decisions about where you should be going next are done via fragment observation of live data that's in the view model. Okay, so if we're talking about the specific scenario, the first thing that we would likely do is have something that occurs in the fragments. The user clicks the last question or something like that. So the user basically triggers the end of the game. And the fragment will then communicate with the view model, hey, the game has ended. And that's where it sort of stops thinking about things. Then the view model takes over, and it's the one that likely has all the information about what the score is, the difficulty, et cetera. And it has all that conditional logic about what should happen next. It updates a live data, which then communicates back to the fragment, and then the fragment's the one that actually navigates to a destination. There is an issue with this, which is that live data is actually designed to hold state, which is something like a button is green, or the user's name is Sally. Data state is not equivalent to events, which are things like, at this one point in time, please show a notification, or please show a snack bar notification, or please animate somewhere. So it doesn't really make sense for navigation to be an event because it doesn't make sense for navigation to be a state. It makes sense for navigation to be an event because you're never really in this state where I am like continuously navigating to win. It is a single event that happens once and then it's done, and you don't want to be sending out continual navigate commands. So we have an engineer on our team that wrote an awesome blog post, which you should also all read. It's only 4 minutes long, and it talks about how to handle cases like this. And the TLDR version of this is that you can create an event wrapper class that wraps around data that is within your live data, and it ensures that the live data only triggers an event once. When you set live data, that action is only triggered once. Okay, so then going back to kind of that flow we were talking about before, in the fragment, the user will click a button or in some way sort of show that the quiz has ended, which immediately sort of shuts off operations to the view model. The view model then contains 2 different live datas representing the events of either an event navigating to the win screen or an event navigating to the game over screen. You do all of your fancy logic with the score and the rules to see whether they've actually won or not. And then, depending on what happened there, you either send out an event on the navigate to win live data or send out an event on the navigate to game over live data. Then back in your activity, you're using observation and match with that event wrapper class that we saw before to say, hey, have I handled this event before? And if you haven't handled the event before, then you go ahead and you call the navigation code that we've seen before. And this example happens to include fragment arguments with a score going along with it. So that was actually a pretty simple example. Let's talk about a more complicated example like a login flow. So let's say that I have a certain number of my screens that I only want visible to a user if they're logged in. And if they don't happen to be logged in, what I want to do is actually redirect them up to a login flow. So to state that again, when I navigate to a new destination or when my login state changes, I want to do some sort of conditional check to see whether I should actually be going to that screen or I should be going to the login flow. So there's a couple of things or ways that navigation can help with this sort of use case. The first is that you can move your login flow to a nested graph. Well, what is a nested graph? Nested graphs are good for things like subflows, for example, login. It's possible to nest one navigation graph within another navigation graph. And how you do that is you simply select the destinations that are supposed to be in the nested graph, right-click them, and say, hey, move these over to a nested graph. When you actually implement that, it makes all those destinations just look like that single bubble that says nested graph right there. OK, so you usually navigate to a nested graph, and you don't navigate to the fragments within nested graphs, making them a fairly isolated flow of screens. And when you navigate it to a nested graph, it goes to the nested graph start destination. Just like your outer graph, the nested graph will also have a start destination. So whenever you say, hey, go over to this nested graph, it's going to be going to that start destination, which in our case is the first screen in our login flow. Yep. And you can see it's represented there by the little house icon. OK, so the next thing that you might want to use is a global action. So what is a global action? Global actions are actions that have a destination that they go to, but they don't have a starting point. So if you look up there at our normal action, that's connecting two different destinations. Our global action there, though, is just a tiny little arrow pointing into our nested graph. So global actions can be used for any destination. Global actions can be used by any destination within your navigation graph to go to a specific navigation. So basically, all of those fragments down there can use that global action to pop over into our login screen, or login flow, which is probably what we want because, again, our use case was that on a bunch of these screens, we're going to want to be able to go up and navigate to the login flow. So in code, a global action looks exactly like an action, but it's not nested within a destination. So let's take a look at that. So first I'm going to show you, this is just an example of our nested login flow. And here is an example of our global action. And you can see that the global action is not nested within a fragment or anything. And that the actually the destination of this global action is taking us into our navigation subgraph right there. OK, so the next thing that you're probably going to want to do for this situation is use a shared activity view model. So as I mentioned before, all of these destinations are fragments right now, and they all share an activity. So the fragments themselves might have view models, but you can also have the activity of a view model, and then all your fragments can know about that activity view model. So within that activity view model, you might have live data that is storing things like an event as to whether you should be currently navigating to login, whether the user is logged in or not, or perhaps what the current destination ID of the destination you're on is. So we just kind of talked about how we would set this one up. This is really dependent on what your implementation of login is and kind of what's going on, but you take that live data and you switch it when the user's login state changes. But for this, we can use something called a on-navigated listener. So an on-navigated listener is called when you arrive at a destination. Ooh, OK. So it includes information about what the current destination is, and it's actually used internally to update things like global navigation UI. So our navigation UI library, what it's actually doing is when you navigate to different destinations, it's using a on-navigated listener to actually get the button to highlight in a bottom nav. So it knows what destination you're on, so it gets the button that's associated in that bottom nav to highlight when you go there. And just a sort of best practice, please remove that listener. So here's what the code looks like. Actually, let me go back. So you take your navigation controller and you just add the navigation listener onto the navigation controller. And then you can set a command like we're seeing here to your view model to update what its current destination is. And that would then be updating that live data that we talked before, which is in your activity view model. And then remember to remove the listener and to add the listener. OK, and finally, we can use pop to behavior for correct login flow behavior. So one of the things that I want is, let's say that I want, when I'm taking this action, so I've sort of finished signing up my user, I want to go back to my sign-in screen. So I don't want to include any kind of intermediate screens on the backstack. So if I want to have a navigation action that looks like that, I can use this pop up to attribute here. And basically what that's saying is remove everything on the backstack until I get to the login fragment, which again is the first screen in my login flow. So from where I am at the end to my start, remove everything in between. And I've also set pop up into inclusive false, so that's not actually going to pop up the login screen itself. So in practice what that does is it pops off anything in the middle there. Right now I only have one screen, but I could have 10 screens right there and it would pop all of those off. So you don't have sort of this weird backstack state where if you click the back button, you'd be like going back into your sign up as a user flow. Okay, and finally, when login finishes from whatever state I'm in, I want to be able to say, hey, pop this entire nav graph off the backstack and go to wherever I was before I got into navigation. And to do that, you can combine both pop up to with a global action. And you can actually say, here, I want you to pop up to login, which is the ID for my entire nav graph, and I want you to be inclusive about that and also pop that off. And so, and what this means though is wherever I am in my sort of subgraph, I can call this global action. It's going to take me out of my subgraph to wherever I was before. Okay, now Dan's going to talk about deep linking.
All right, we have 8 minutes and 49 seconds left. Let's do it. All right, one of the challenges that navigation solves is deep linking into an app with a combination of fragmented activity hierarchies. And this is the kind of deep links that you use in the case where you have a pending intent, such as a notification. Now, creating a deep link pending intent involves using the nav deep link builder, the navigation graph, destination, and pending intent. Now, if the graph is a simple one like this, with a start destination and sibling destinations, the backstack from the deep link will look something like this, with the start destination and the selected destination on the backstack. If we put the entire game into a nested graph, our backstack would be generated from the start, with the start destination from the main graph, the nested graph, and the selected destination. You can also create deep links that can be executed easily from the web or from other apps. We create our deep link right in the navigation editor, and this creates a deep link tag in the XML. Now, since the fragment we're deep linking into requires an argument, we need to put the argument in curly braces as part of the deep link URL path. And you also need to add the correct intent filters into the manifest. Now, this is done for us automatically by inserting the nav graph tag with the navigation graph ID. And it'll generate all that stuff automatically. And now Lyla is going to talk about instant apps, how you can apply all of this there.
Okay, so the topic of instant apps probably takes more than 7 minutes to explain. So hopefully we'll be coming out with samples soon that you can see all of this in. So now that you know a little bit about how deep links work with navigation, that allows me to talk about instant apps. So instant apps are native Android experiences, but you're not actually required to install the app. And they work because you download modules kind of on demand via instant apps, which means also that usually a structure for instant apps is going to contain a lot of different modules. So in this case, well, in a basic case for an instant app, you're going to have a module for your installable app, and you're going to have a module for your instant app, and then you're also always going to have a base feature module, and then you're going to have a bunch of feature modules as well. Okay, so that's a lot of modules. What does navigation actually look like with this? So if you want to get instant apps to work with navigation, you're going to end up making a navigation graph for every single one of your feature modules, both the base feature module and your other feature modules, as we've seen here. And none of these feature modules, unless they already reference each other, are going to have things in their nav graphs that directly reference other feature module nav graphs, because remember, these are supposed to sort of be isolated different features for instant apps to work. Okay, and then you're also going to have a kind of main navigation graph that's going to be implemented both in your base feature and in your installable app. And it's very important that this navigation graph has the same name, because when you're in your installable app, the actual main nav graph file is going to override the one that's in your base app, which gets some magic to work, which we're going to talk about now. So looking at what's in the main nav graph for your installable app, you actually have all of the as subgraphs or nested graphs, you have all of the navigation graphs that are for each of your different features nested within there. And then in your base feature, and remember this is the one that gets overridden, you have a bunch of activity destinations that use this implicit activity deep link syntax, which is probably the first time that you're seeing this, but that essentially says when you're navigating to this activity destination, that's actually going to make an implicit deep link to go to that URI. Okay, so what happens when I actually want to navigate from the base to one of my features? Well, if we're talking about an installable app world, you guys are really getting your money's worth. We're getting full 40 minutes. In your installable world, your nav graph for your base navigation, well, this is the same for both of them, is going to have an action that is navigating you to the destination called a_dest. Okay, so what does that refer to? Well, in your installable app, you have this nav graph that includes all of the other nav graphs that are in your app, which includes this nav graph A. And in nav graph A, we will see that the actual nav graph itself has a destination a_dest. So when you trigger that action, it actually kind of bubbles up and ends up calling this, this ID that is in your nested nav graph there. Okay, so let's talk about if we were in an instant world. So in an instant world, you are still triggering an action whose destination is a_dest. And in the base main nav graph, we have that implicit deep link that I saw before, and that ID is actually a_dest. So it's using a implicit activity deep link here, which is what you need to be able to actually launch in an instant app world between different features. Okay, and then finally we can see in the actual graph nav graph, this is where I set up that deep link. So I'm both sending out the implicit intent, and then within the nav graph, I'm also have this line to actually set up the deep link. Now, if you want to go from one feature to another feature, so let's say that you want to navigate from A to B, in my nav graph B, I'm going to have another one of those deep links set up for that URI. And then in nav graph A, it's really easy. I have an activity destination that has an implicit deep link for nav graph B. Okay, so that was a lot of adventure. There's even more adventure to be had online. So we have documentation for this. We have samples for this, including the sunflower example, which is a comprehensive jetpack example. And we have, again, shameless self-plug, a code lab, which if you haven't used navigation before, you should totally check out. All
right, and thank you. You can always ask us questions, follow us on Twitter, all that kind of stuff. So.